the next data structure. So this is linked list. So can anyone tell me what kind of a data structure is this? Is this a linear or non-linear? Anyone? Linked list, is it a linear or non-linear? Whenever we present a
Linear.
title, you have to know whether it is a linear, dynamic, everything you should know. Is this a linear or non-linear? Linear, right? I think I show you the classifications before also. Except the graphs, trees, hash tables, all the others are linear. It follows a linear data structure. And only array is a static data structure. From linked list, stack queues and all, everything belongs to a dynamic data structure. So you can see, actually why this linked list came is, it came as a replacement to overcome whatever the drawbacks we had in arrays, right? So array is a static data structure, which means the maximum capacity of an array should be known before the compilation process. I think I told you before also, whenever you want to initiate an array, right at that moment, you should know what should be its size, because you cannot change its size during the runtime. So before the compilation itself, you should literally know what should be the size, 100 or 100 or 200 or whatever, but you should know that. So practically defining such static size before the compilation of a program reduces effective space utilization. So maybe without your knowledge, you thought like 100 space is enough and you already created. But all of a sudden, you need to increase another 50 slots. Can you do that? No. What do you have to do? You have to again create another array with that 150 capacity. Or even the other way, you have already created 100, but you need only 50 slots. Can you simply remove that 50 additional one? No. It is static and it is a wastage of memory. So since there is a very problematic in the space utilization thing, we try to go with another data structure, that is the linked list. In addition to the effective space utilization problem and the static data structure problem, even the insertion and deletion in array, as I told you before, also require a more lot of data movement, right? Whenever you want to insert and delete, you try to move. So even that consume a lot of processing power. So to overcome these drawbacks, I mean the disadvantages of array, we propose the other data structure that is called as linked list, right? So linked list means this is basically a data structure which helps to eliminate the drawbacks we obtain from the array data structure. So first one, this use a kind of a dynamic memory management problem. So here, whenever you need some additional data, you can always create it. And whenever you don't need that, you can always release it, right? So this is a way of dynamic memory management. So because of this is called as an efficient space utilization, right? And also, because of this dynamic data structure, right, even you can add or delete from any position. If you want to delete, or even if you want to insert any data at any position, it is I will teach you like how the data structure is behaving. So you can simply plug them and you can simply unplug them. So that is how this kind of a data structure behave. So this is called as a linked list. Okay, so you can see here it is also a linear data structure, but the elements are not stored at a contiguous memory location and they are always referred using some pointers. Just like the index, here we have something called as pointers, right? A linked list consists of nodes where each node contains a data field and a reference link to the next node in the list. So maybe you just think this is a node, right? You have another node. Like a train, it is there. You have different nodes, and this will have a reference what should come next to it and what is before this. Similarly, this will have detail, which is a pointer, which will come before this and which will come after this. So as you can see, all these are connected using some pointers now. So simply, even if you want to add something new, like imagine you're going to add something new, you can simply remove this pointer from this this position, and maybe I need to connect it to this one. You try to unlink from here and just link it here. Even if you want to delete this element, just remove this link, delete this element, and maybe to the next one, you just connect. So this way, it has a kind of a dynamic allocation of memory. And as elements are added to a list, memory for a node is dynamically allocated, right? So you can see a linked list, just like the arrays, which has index and the value. In the linked list, you have a node, and each node contains a data field and a reference to the next node, right? So maybe if this is your data, right? If this is your data, you also have a set of references which comes to the next node in the list also here, all right? So that is a small introduction about the linked list. Now we will see how is it actually. So see, you have a data structure like you have quiz today, just an example, right? So here, everything is called as a node. You is a node, have is a node, quiz is a node, and today is a node. So here, generally, the node have, if you take a node, it will typically have two components. One is the data. The data here is you. And next one is the next pointer. It will always say what is the next position to this, right? So maybe if I have the link, if I have the link connected like this, and right after this, you have this, and maybe after this, you have this. If the link is pointed like this, you have to read it the other way, like you quiz today have something like this, right? So it will always have a data and also the pointer which shows what should be the element, the next element. Okay. In addition to these nodes with the data, you also have two extra persons which are called as head and null. Head, null or tail, right? Head mean the linked list is accessed through the head node, which points to the first node in the list. So this is your first node, and it is always pointing to the first node. Then tail node mean it always points to a null pointer, which means that is the end. It just specifies that is the end of this linked list. Okay. Now you can have a look. You can see from here, right? Just a moment, right? So from this, you can see you have data nodes, and the first node is connected to head, and the last node is connected to a null pointer, and every node has a reference to the next node here, right? So this is a head node and the tail node. Now, if you can see here, based on these connections also, we classify the linked list into three. One is called as singly linked list. The other one is called as doubly linked list. And third one is called as circular linked list. Singly list means simply it is single, right? So you have one data node and it only points to the next node in the sequence. The one which I showed in the previous example is also a singly linked list, right? So here, if you want to traverse means just accessing all the points is done only in a forward direction. First you access this, then you access this, then you access this and go on. This comes in only one direction, right? So this is a singly linked list. Then if it is a doubly linked list, just like the previous one, but you can see it has a reference to both. It has reference to both sides, right? So even the next one is also shown. The previous one is also shown. So that is why it is called as a doubly linked list. But the main problem is traversal can be done, although it can be done in both forward direction and backward direction. The main problem is it requires additional memory. I think it is very straightforward, right? Because you have to refer the next one also, the previous one also. Because of this, you have a more processing power. The other thing is called as circular linked list. It can be either singly or doubly linked list, but the last node points back to the head node. So you can see there is a circular motion from head, it moves and then come back to the head again. From the tail node, it comes back to the head again. See, it creates a circular structure. In this case, this is implemented with a singly list. If it is a doubly circular linked list, it will also have pointers to the previous one, and again it forms. Okay, so these are the three types of linked list. Okay. I think we can continue this in the next class. I will just give you a quick introduction. Just like the previous arrays here, the basic operations in the linked list is also creating an empty list, insertion, deletion, and searching. Although the operations look similar, depending on every data structure, the process is different, right? So I will quickly go through, but again, in the next class, we will learn very deeply also. So first one here is initialize list. So here the initialization of a list begins with this kind of a command, initialize list, and this will help you to initialize the list as an empty list. Just like the array, when this linked list is also created, this is also empty. And we have a node called as head. After that, inserting in a linked list. Generally, inserting, as you can see, if you want to insert any data in the linked list, there can be differently three types of insertion possible. So if you take a linked list like this, maybe there's a singly linked list or whatever, and we have a head here, and we have a tail here, right? So either you want to insert a data at the start point, or you want to insert a data at the last point, or you want to insert a data at the middle point. All these three things will follow different structures, right? So just to quickly go through, I will say like if it is a insertion at the front, what happens? Simply you try to insert and move the pointer from the previous one, and now from the inserted one, you point it to the head. Likewise, if you want to insert something at the end, maybe this one is already pointing to the tail. So now what you do is try to remove this link, and maybe you are inserting another value here. You make a pointer from here to this link. Okay. So this is inserting at the end. And likewise, if you want to insert something in the middle, so maybe I'm going to insert something in the middle main, what you can do is simply unplug. Where is my, this one also go? Yeah. Unplug from here, and you just try to make the link from here to here, then from this here to here. So this is way of inserting the data in the linked list. So I can quickly show you the, if it is inserted front or insert the first element, you can see the first element is inserted, which is pointing to the head. And if you want to insert another element 3 at the front knee, you just remove the link, the pointer which is connected with the head, you unplug them and you again point it to 3, and from this 3 you go to 5. And after a given node mean here, like maybe you want to insert number 7 between 5 and 8, simply you remove the pointers in order. And if it is the end of the linked list, simply the last node will be pointing to the null. Okay. And just like the insertion, deletion is also very simple here. If you want to remove an element at the first, simple, just delete that, and the second element will become the first element and point it to the head node, right? Then if you want to remove an element at the last, same way. Whatever the element which was there at the first, you remove them. Then the element which was at the second last will again point it to the null pointer, right? And remove a given element of the list means something in the middle. Just remove the pointer pointing to the next and just plug it in the middle. That's all, right? So this is how you do it, right? So I think that was a small introduction about this linked list. I will upload the slides. Please go through and come to the next class, right? So if you have any doubts also, you can bring to the next class, okay? With this, I stop the session today. Do we have any doubts which we can discuss now? Any doubts?
No, ma'am.
How about others?
No, ma'am. No, ma'am.
Okay, I think okay. So I will upload the slides also. Please go through and come with any doubts. In case you have any doubts, please bring it to the next class. Okay, then see you all next week then. Thank you.